salesperson earns a base salary of $300 plus 15% commission on his sales. So what this means is the person starts off with $300, and for everything that he sells, he earns 15%. So if he sells $100 worth of goods, he gets $15 to add to his starting value of $300. If he sells $1,000 worth of goods, he'll get 15% of that, or $150, and he can add that to his original $300 that he started with. So this is a linear relationship. Now, what characterizes this linear relationship is this percentage, because this percentage is actually a rate, and rates generally give us a straight line relationship, or a constant rate does. So the relationship here is related in the equation like this. The salary is going to be the $300 he starts with plus 0.15, that's my 15% as a decimal, times the amount he sells. Okay, so we're going to assume that we know that this is a straight line relationship, so we want to find what this looks like. And really we just need 3 points to be able to establish a straight line. So I'm going to make my table of values here. And so I have my independent variable is my sales, how much I sell, and my dependent variable is my salary. So the salary depends on the amount I sell. My input is sales, my output is salary. My input is X, my output is Y. So I'm going to start with 0 sales, because that's always a good place to start. How much do I have to start with? Well, my word equation tells me I start with $300. And we don't really know what this guy's selling, but let's assume he's selling thousands of dollars of goods. So we're going to say he sells $1,000. Well, using the equation, again, remember the equation allows us to get coordinates, which we can then put on a graph. So I'm going to go 1,000 times 0.15, that's 150, plus the original 300, so he has $450. And let's say maybe, let's see what the scale is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just go to $10,000. Okay, so he sells $10,000. That's 1,500 in commission, so 0.15 times that, plus my original $300 is going to give me $1,800 in salary. So I need to then accommodate, so 1,800, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go up to here. So let's say that that's 2,000 here. Okay, so that's 1,000. Okay, so that's going to be 300 is going to be right there. So 0 sales is 300. I'm going to go up by 1,000, so 1,000. 2, 3, 4, 5,000 here. $5,000. 6, 7, 8, 9, 10. I'm going to put 10,000 here. Now you could use whatever scale you want. Okay, so it's up to you. Just make sure there's no right scale. There's an appropriate scale, but there's no right scale. So I have my 0 point here. At $1,000 of sales, I earn $450. Okay, so 400, there's 400. 500 is right about, so about $450 is not, it's just right about there. Okay. My 10,000 is going to earn me 1,800, so maybe right about here. It's kind of hard to see. And I know this should be linear, so I just make sure that my points kind of line up. Yeah, they line up, means I've probably graphed it correctly. And then what I really want is this straight line relationship. There it is. That's what I'm looking for. Okay, although I've only used 3 points, and you can use any 3 points you want. The only thing that I would really expect you to do is always graph the initial coordinate. Okay, you can use some other points if you like. So there it is. There's my straight line relationship, and that's my relationship of salary related to the amount he sells. And it's going to look like this. So this is just a regular XY equation. We want to draw the straight line through this. Again, it's always a good idea to put a 0 in here. I want to go in the negative, so I'm going to start with 0 here. X is 0, Y is 5. I'm going to put maybe negative 2 in here. Negative 2 times 3 plus 5 is negative 1. Start graphing these coordinates. Okay, and I just want to make sure my points fit on my graph, so I don't want to go too high. So it looks like if I go to x equals 1, y equals 8, and I don't know if I can go much higher than that. Okay, now if you want to scale your axes, you're more than welcome to do that to be able to fit your points on the line, but I've kind of just adjusted my choices here to fit the graph. Now, it doesn't matter which 3 points I use because any 3 points should give me the same pattern. And again, it's not the points that are important, but the pattern. Okay, and the pattern looks like this. Okay, it's going to be a straight line. And because it doesn't seem to have any restrictions on this, because it's not a word problem, we should just assume that it's going to go beyond the first and last coordinates. And if you're not sure, I can just keep on plugging in more coordinates. Okay, maybe I'll choose negative 4. Negative 4 times 3 is negative 12 plus 5 is negative 7. So negative 4, negative 7. 4 is right about there. Okay, so I can use more coordinates if I'm not sure. It is a good idea to order them, but again, in this case, it's not always necessary, but it's always good to keep them in order to keep them organized. So we've been connecting this idea of equations, allows us to get tables, which allows us to get a graph, but we can always do it the other way around. So we can always use a table. Somehow we can come up with an equation or a graph to somehow come up with equations. That's going to be our challenge in the next section. So what we want to make sure that you're connecting then is this idea between the graphs, tables, and equations. There's this interrelationship between the three. If we have a pattern, there must be some mathematical connection here. And we must be able to generate tables of values from this pattern, and vice versa. Okay? And what we've done is we've gone from equations to tables to graphs. We want to figure out how to go the other way around as well. So that's going to be for some later classes.